In this video, we're going to dive deeper into sampling and estimation by looking at how to calculate the key statistics for sampling and estimation, including the expected proportion, the variance, and the standard deviation. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The reason why I'm specifying the expected proportion rather than the mean or the expected value is because the way it works for sampling and estimation is a little bit odd. The expected proportion of any given scenario is equivalent to the population proportion P. No calculation needs to be done. Why? Well, let's take a look. What we have here is the probability distribution of tossing X number of heads across 3 different tosses. If you were to find the expected value of this, well, all you would do is multiply each probability by its corresponding X value and then add them all together. This is standard discrete probability fundamentals. To find the expected proportion, we're going to do something very similar, but we need to rewrite our table in terms of P hat rather than in terms of X, which we're going to do by using the P hat equals X over N equation. If we calculate the expected proportion using the same methodology, we're going to get a half, which again is equivalent to the population proportion of getting a head. We expect heads and tails to be a 50-50 outcome. The proof of this actually comes from the binomial method of calculating the expected value, NP. All we're going to be doing is replacing that X value with P hat, since we're trying to find the expected proportion, not the expected value. But P hat is just X over N, so let's replace it with that instead. Now here's the trick. N can be thought of as a coefficient of X, and so using the linear simplification for expected value, we can take that coefficient out the front of the expected value equation. All we have to do from here is replace E of X with N times P, and then simplify that full equation. What you'll see is that the N terms cancel out, and it just goes back to P. So to save you the effort, instead of trying to calculate the entire distribution and then do the expected proportion from that, just find the population proportion. The equation of the variance is also slightly different, and once again, its proof will also come from the binomial distribution way of calculating it, NP1 minus P. So to start with, we're just going to replace variance of X with variance of P hat, and then replace that P hat with X over N, since that's what P hat actually is. Just like before, N can be considered a coefficient of the X, and so using the variance version of the linear simplification, we can take it out the front as well, and then simplify that result. Let's apply that to this question, where we have a box of 2 red pens and 8 blue pens. A random sample of 4 pens is taken from this box, and we're asked to calculate the variance of the proportion of red pens in the box. All we need to know is what N and P are. N is going to be 4, since that's our sample size, and P is going to be 2 out of 10, or 1 out of 5, since that's the number of red pens in the box divided by the total number of pens in the box. Substituting into the variance equation is going to get us 1 out of 25. The good news is that this one hasn't changed at all. It's still just going to be the square root of variance. So if we apply that to the previous question, all we're going to do is square root the 1 over 25 to get 1 over 5. So in summary, you just have to be a little bit careful when it comes to calculating the statistics. If your question is mentioning things like proportion, then you're going to be using these equations. And the good news is that you don't actually have to memorize these equations. They appear on your formula sheet. So all you're going to do is look them up on your formula sheet as soon as you see that it mentions proportions. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.